Hello and welcome to Cisco Router Training 101. My name's Don Crawley. I'm from soundtraining.net. We're the Seattle, Washington-based publisher of learning resources and provider of accelerated training for IT professionals. This time we're going to cover Cisco Router Access Lists Part 2, Advanced Features. This is Part 2 of our three-part series on Cisco Router Access Lists, and this is based on Chapter 11 in my book, The Accidental Administrator Cisco Router Step-by-Step Configuration Guide. The book is not required, but if you'd like to get a copy, I'd love for you to have one, and it's available through the usual online resellers and through soundtraining.net/bookstore. This demo is based on Cisco iOS version 15.1. The things I'm going to show you are supported in most versions of the iOS. There's a few things that are only supported since version 12, and one thing in particular that's supported since version 15, and I'll try to point those out as we go through the demonstrations. In this video, we're going to cover extended access list. We'll talk about how to add comments to your access list. We'll show you how to use object groups to group different IP addresses or services together. We'll also show you how to use time ranges so that you can apply an access control list only during certain hours. Maybe you want to restrict web access late at night, for example, and you can do that with time ranges. And we'll also show you how to use named access control lists. During this video, you'll hear me use the terms access list, ACL, and access control list interchangeably. They all mean the same thing, so don't let that confuse you. Our other videos on Cisco Router Access Lists include Part 1, which covers the fundamentals, including standard access control lists, and Part 3, which includes IPv6 access lists. Here are the prerequisites for this lesson. You'll need the following: unrestricted privilege mode access to a Cisco router, understanding of IP addressing, including subnets, dotted decimal notation, and CIDR notation, and familiarity and experience working with Cisco iOS standard access lists. I'm going to assume you've already had some experience in that area, so I won't be going over some of the basics. Our equipment software requirements: I'm using a Cisco Model 1941 router. You can do this with pretty much any Cisco iOS-based router. It's not going to work with a Linksys home router, but an iOS-based device it should work. You'll also need a computer for your management workstation connected to one interface on the router, a console cable, and terminal emulation software. The one I'm using is PuTTY. Here's your disclaimer. The video is provided solely as a courtesy to you, our viewer. There are no guarantees whatsoever, never are. Do not attempt these procedures on a production router without first testing them for security and suitability in a lab environment. Performing these procedures may open your router to the public internet and subject your network to attacks, so please make sure you have current backups and take precautions including data encryption and additional access controls to protect sensitive data, which presumably you do anyway, right? So, what is an extended access list? Well, just like a standard list, it's a way of identifying traffic flows, but an extended list gives you many more filtering options than a standard access control list. For example, you can filter on the source IP address like a standard, but with an extended, you can filter based on the destination IP address. You can also look at protocol types and port numbers. We'll go over those in more detail in just a moment. Extended access control lists are numbered 100 through 199 or 2000 through 2699. Most people probably stick to the 100 through 199 range, but the router really doesn't care. Either way works. Now, as we mentioned, you can filter based on source and or destination IP address. So, for example, we could use a traditional Class C network address of 192.168.1.0/24, which in the syntax used with an extended list would equal 192.168.1.0 with an inverse mask of 0.0.0.255. By the way, if you looked at the previous video on standard access control lists, you may recall that with a standard ACL you can use CIDR notation, a slash value. That doesn't appear to be the case with an extended list, at least not on the routers where I've tested it. You can also use a subnet address, such as the one I'm showing you here of 10.1.2.64/26, which in access control list syntax equals 10.1.2.64 with an inverse mask of 0.0.0.63. Or you can specify an individual host or node, such as what you see here, 192.168.1.1, which would equate to, in access control list syntax, 192.168.1.1 with an inverse mask of 0.0.0.0, which tells the router to match all 32 bits. Now, if you're working with an individual host, you can also just use the host command and then specify the IP address. So instead of using the inverse mask, you could say host 192.168.1.1. And that, by the way, works in both standard and extended access control lists. As I mentioned, you can also filter based on protocols. So you could filter all IP traffic or ICMP traffic. Maybe you want to block pings or source quench updates. You could filter based on TCP or UDP, and you can even get into port numbers if you want to. And that's what the next part is. This is port numbers. And when you're filtering TCP or UDP traffic, you can use operators to match certain traffic types. So you could use the EQ operator to equal and then specify an individual port number, so maybe EQ80 to block World Wide Web traffic. Or greater than, you could specify GT and you could say greater than, say, 1023 to block everything except the well-known port numbers. Not sure why you'd want to do that, but you can. Or less than, same thing. NEQ is not equal to, so you could say I want to block everything except a particular port number. And you can also specify a range. So you have quite a bit of flexibility there as well. Now here's the syntax for an IP extended access control list, and let's just go over it line by line. So the first line, access list 100, that just tells the router that this is an extended list. Deny, obviously we want to block this particular type of traffic. We're going to use TCP for the protocol type from any source going to the destination network of 192.168.101.0 that's equal to telnet. Now, we could also say 23 instead of telnet there for the port number. The next one is to deny ICMP traffic. That's typically associated with ping, but there are other things that ICMP is used for as well. Going from any source, going to the host 192.168.0.101, and in this case, the ICMP packet type is an echo packet. So we want to block that. The next line is a permit IP traffic from 192.168.101.0 going to any destination. Now, the next line, the fourth line, is the permit any, which really makes the previous line, line 3, redundant, but I included it just so I could show you the syntax. So IP any just says permit any IP traffic going from any source to any destination. So let's work through an exercise together. Now, this diagram may be familiar to you if you watched our first video in the series on access control lists, but this is a simple 4-network diagram with a single router with 4 interfaces. One is connected to the internet, and then we're also connected to sales managers and R&D. Our objective in this exercise is to block users in the sales LAN at 10.3.0.0/16 from using telnet to reach the R&D server at 10.1.0.1, but we want to allow all other access. So all we want to do is keep the sales LAN users from telnetting into the R&D server. How do we do it? Well, first of all, we're going to create an access control list. And as you can imagine, we want to specify the sales as the source of the traffic and that server as the destination. Here's the syntax. We'll use access list 100. 100 is any number between 100 and 199. Then we're going to say deny. Then the protocol type is TCP. The source IP address is all nodes in the sales LAN, so that's 10.3.0.0 with an inverse mask equaling a 16-bit mask of 0.0.255.255, going to host 10.1.0.1. Notice how we specify the individual node here. And then finally we say equal 23. We could also say equal telnet. Either one works. Now, are we done? Well, no, we still have to permit everybody else. So that's the next statement, access list 100, permit IP from any source to any destination. So that takes care of the access list. And are we done? No, because we have to apply it to an interface. Now, take a look at this diagram and think about the fact that there are 2 possible places where we could place this access control list, and both would work equally as well at accomplishing the objective of the exercise, which is to keep sales from accessing the R&D server. But one is better for reasons unrelated to the objective of the exercise. So we could either put it on G0/0 or G0/2. And the better solution is to put it on G0/2 because that's closer to the source of the packets. So we'll use the IP access group 100 statement and then in or out. Well, in this case, it's in because, again, in or out is from the perspective of the router. These packets are coming in to the router. Now, let's go back and revisit the question about whether to put the access control list on G0/0 or G0/2. We could put it on G0/0 outbound and it would work perfectly well. But then the router would have to process the packets on the inbound and the outbound interface. By placing it on G0/2 in, the router only has to process it on the inbound interface, thus saving some processing power on the router. Either one works, but G0/2 is a better solution because it allows you to conserve router resources. Now, there's other things we can do with access control lists, such as comment them. And if you've done any coding at all, you know that one of the best things you can do in coding is to put lots of comments in. Well, on a Cisco router, we use the remark statement to comment our ACLs, so we can tell later on what it was that we were thinking when we decided to create that particular line in an access control list. So the syntax is access list 10, remark, block Topeka office. You could also use it with an extended list. And that simply is a way of saying, okay, I remember I was setting this up to block users in the Topeka office. We can also use object groups. And the way to think about object groups is that it's kind of like how you take users, say an Active Directory, and you put them all in groups and apply settings to the groups just once instead of multiple times to each individual user. And that's kind of what an object group is. There's two types of object groups that are supported on a Cisco router. There's network object groups and service object groups. And with a network object group, you can specify a network. So I could say, okay, I want to operate on the 10.1.0.0 network, and I want to group it with the 10.2.0.0 network. Or you can specify any, you can specify an individual host, or you can specify a range. Any one of those four work, and you'll see them. I'll demo them here in a moment. Now, object group service types allow you to specify IP traffic. You can specify TCP and UDP services, such as web port 80 or telnet port 23, encryption or encapsulation protocols, such as ESP or GRE, routing protocols, such as OSPF or EIGRP, and many other types of services as well. So this allows you to say, I want to just block all port 80 and 443 traffic, so I could create a service object group and specify 80 and 443 in there, and that way I only have to put it in one time instead of creating a separate line for both port 80 and 443. Now, creating and using object groups, well, first create the object group in global configuration mode. So here you can see I used the object group statement, then I specified what type. Again, it's either network or service, and then I gave it a name. That's just a text string, and I like to put them in all caps, just makes it easier for me to see in a configuration, and that way I tend to recognize it as a name. Then you use it in place of the network or service statement in the access control entry. So access list 100, permit IP from source object group accounting going to any destination. So I may have put in 2 or 3 networks in the object group, and this way I can operate on those 2 or 3 networks with a single statement. You'll see that in a moment when I demo it. I can also use time ranges, and time ranges can be used to apply an access list only during a specific time. You can either do periodic or absolute. If you do periodic, you can choose weekdays, weekends, daily, days of the week, and with absolute, that's specifying a particular time, point in time, and operating only during that time. The way you do it is you create the time range, and then you use the time range option at the end of an access control entry to apply it. The last thing I want to show you is named access lists, which are available in more recent versions of the iOS. If you're running, say, version 11, you're not going to have support for named ACLs, but most recent versions support named ACLs. And it's simply a way of putting a name on the list instead of a number. So here you see I created the list with the statement IP access list extended block underscore sales. Not sure why the underscore is not showing up there, but it is there. Then I used a deny statement to deny IP traffic from source 192.168.50.0 going to any destination. Then the permit IP any after that, otherwise all traffic would be denied. Then I went to an interface and I used the IP access group statement along with block underscore sales out to apply the access list to a particular interface. So it's very similar to how a numbered list works, but you have the benefit of using a name, an easily recognizable and a very descriptive name, such as what you see here. So let's do the demo. And the first thing we're going to do is I just want to ping the router, which is at 192.168.1.10. So let's ping it. I'm in PowerShell here, 192.168.1.10. So that's reachable. Now let's try to telnet into it. So we'll do telnet 192.168.1.10. And there's our prompt. We'll go ahead and authenticate and then back out. So as you can see, that's successful. Now what we want to do is we want to go back to the router and block telnet traffic. So let's go back to the router interface. You'll notice that we're on router 2, and we're going to use an extended access list to block telnet traffic to the outside interface on the router. Let's go into global configuration mode, configure terminal. Oops. And we're going to use the command access-list 100, then deny TCP traffic from source. Well, any source. We could specify it if we want, but we'll just do any. Going to host 192.168.1.10. That's the outside interface on this router. Equal to, and we could either specify telnet or port 23. I'll do 23, but I'll put in a question mark just so you can see the various options that are there. As you can see, there's quite a few options. And if you don't see the name, then you can use any of the 65,500 port numbers. So we'll just say equals 23. Now let's create the line that allows all other traffic in. So access-list 100 permit IP any. And now we need to apply it to an interface. So let's take a look at our interfaces. We'll use the command do show IP interface brief. So here you can see that 192.168.1.10 is connected to our gigabit Ethernet 0/1. In real world, you probably know all that, but I just wanted to show you this. So now let's go in and apply the access list. So we'll do interface gig 0/1, and we're going to do IP access group 100 in. In or out? Well, in this case, because the traffic is coming to the router, toward the router, it would be inbound. Now let's go back to PowerShell and see if we can reach it. So let's start by pinging the router again, just to make sure that we can reach it. So we'll touch the up arrow a couple of times, and success with the ping. Now let's try the telnet. Looks like it's not going to work. So you can see the granularity, the surgical nature of an extended access control list. It gives you much more power, much more control, because in this particular case, we're still able to ping the router. We just can't telnet to it. And you can do that with all of the different TCP and UDP protocols, as well as ICMP and lots of different options with an extended list. Now let's take a look at a couple of other things. So suppose that I want to put a remark in there. Well, I can do the command access list 100, and then I can say remark and block Topeka office. Sorry for all you folks in Topeka. And now if I take a look at the running config, let's do that. Let's use the command do show run and section access list. There you can see that I've put a comment in, and it says block the Topeka office. And so later on down the road when I'm looking at the configuration, I don't remember everything I did. At least I've got some comments to help me there. Now I can also do object groups. Let's create an object group and show you what I was talking about. So we're going to create the object group, a network object group called accounting. So object group, and then the type. Put in a question mark so you can see either network or service. So we'll do network, and then a text string, accounting. And again, I'm just using all uppercase as a personal preference. That's entirely up to you. Now I need to specify either my network or my host or the other options that we talked about earlier. In this case, we'll say 192.168.10.0, 255.255.255.0. And then I'll show you a little trick that's available on newer routers. We can say 192.168.20.0, and check this out. I can, instead of using a mask, I can put in CIDR notation. Again, that's only on newer routers. Older ones won't support it, but certainly they'll all support the dotted decimal notation. Let's put in a host as well. So host 192.168.30.3. And now to use it in an access list, I would use the command access-list 100 deny IP going from any source to the destination specified in object group accounting. That way I don't have to create 3 separate lines for each of those 3 network entities. Now, as I mentioned, I can also use time ranges. So let's take a look at time ranges. So suppose that I want to allow World Wide Web traffic only on weekdays from, say, 8 a.m. to 5 p.m. So I could create a time range. Time range. And then I just give it a text string. You know, I could call this Fred and Wilma, but I'm going to call it weekdays. And notice that I'm now in time range configuration mode, and we're going to specify periodic, but let me put in a question mark so you can see the other options. So we'll say periodic. And again, here's a question mark. Notice what the options are. Let's just say weekdays. One thing that's kind of cool is you could actually say create one that's every other weekday. So you could say Monday, Wednesday, Friday if you wanted to, but we'll just put in weekdays. And then we need to put in the hours. So 0800 to 1700. So I've created the time range weekdays. Now I'll use it in an access list. So access list 100 permit TCP from any source to any destination equal to 80 time range time rant. Sometimes that's more appropriate, right? Then weekdays. And it's there. So that's kind of handy. You know, maybe you want to block web access during off hours or something like that, and you can do it with a time range command. The last thing I want to show you is the use of a named ACL. I already showed you that in a screen capture, but let's do it live just for grins. So IP access list, and you have to specify extended or standard. Let me put in a question mark. So here you can see there's several different options there. We're going to say extended, and then block underscore sales. Now, what do we want to do? Well, we want to deny IP traffic from 192.168.1.0 with the inverse mask of 0.0.0.255 going to any destination. Now let's include the permit any statement. So permit IP any, and we've created the list. And let's take a look at it. So we'll use the command do show access list. And there you can see the access list 100 that we created earlier, and there's the block sales access control list that we just created just now. And one of the cool things about access list now is that you'll notice that there are sequence numbers. See those to the far left of each line? Well, if we want to insert a new line, we can do that. So let's add another subnet in there. So this time, all I'm going to do is I'm going to say 15, because the sequence number comes first, then deny IP 192.168.2.0, inverse mask of 0.0.0.255 going to any destination. And once again, let's use the up arrow to use our command do show access list. And there you can see the new one inserted in between line 10 and line 15, or sequence number 10 and 15. The other thing that's kind of neat is if I want to get rid of these, I'll just show you a little trick in case you don't know this. Let's do no, and let's get rid of access list 100. So where was access list 100? There it is. So I'll just use my mouse to grab it and then right click. Notice that the cursor is still up there. So all I do is right click and it pastes it in. I hit enter and it's gone. Now here's another trick. Let's use the up arrow and let's go back to where we created our named ACL. There it is. And I can actually use command line shortcuts to move my cursor around. So if I want to go to the very start of the list or the start of the line, I use Control A, and notice that. Isn't that cool? So now I can just type no and hit enter and it's gone. Pretty slick. Let's make sure they're gone with the command do show access list, and indeed they're all gone. The last thing I want to show you before we wrap up is just how a packet is processed if there's an extended access control list on the interface. I'm not going to go through this step by step. You may want to pause the video and just take a look at it, or it's in the book as well if you'd like to pick up a copy of the book. But it is interesting just to see the order and how it processes things. First thing it looks at is there a list on the interface? Then it looks at source address, destination address, protocol, and protocol options. And like I say, you can stop it and look at it a little more closely if you'd like. Other types of access lists are also supported on routers. I'm not going into those here, but there's reflexive, content-based access control lists, authentication proxy, and turbo ACLs as well. And we may cover those in a future video, but I just wanted to make you aware of those for right now. In part 3 of our 3-part series on access control lists, we'll cover IPv6 access lists. If you'd like more information, we've got it at our website at www.soundtraining.net. I blog at soundtraining.net/blog. You can subscribe to our newsletter. Also follow us, like us on Facebook. Please like us on Facebook. You can also follow our tweets and join us at Google Plus as well. If you'd like more videos, we've got them at soundtraining.net/videos. If you'd like the companion book, it's available through the usual online resources and at www.soundtraining.net/bookstore. Well, I hope it's been helpful for you. For soundtraining.net, I'm Don Crawley. I'll see you next time.